Good morning everyone, we are from Coffee into Code and today our team are going to introduce about our food delivery order tracking system. First, we will start with our system synopsis. This system is a food delivery order tracking system. It was designed to provide convenience and transparency of online food ordering service. This system allows customers to place food order and track their delivery status easily. This system consists of three subsystems, which is user authentication system, ordering system, and delivery tracking system. Next, we will go to system objectives. This system was created to provide delivery tracking. Customers can track their food orders in real time using this system. Besides that, this system also was created to improve customers' experience. This system provides a user-friendly interface for a better food ordering experience. Customers can also clearly track their food's estimated arriving time.
Now, I will explain how to use the system, including the key features and user workflow. Our system includes several key features. First, user authentication allows users to log in using their username and password to access the system. Next, users can browse the menu to view the list of available food items. Users can then select food items, enter the quantity, and create the order. The system will automatically calculate the total price. After that, users can choose whether they want delivery or pickup from the restaurant. Finally, users can track their order status and view the estimated delivery or pickup time. This is the workflow for the customer. First, customer log into the system using the login function. Next, the customer accesses the dashboard to view available options. Then, they can view the menu and places an order by selecting items and setting the quantity. After that, the customer choose either delivery or pickup. For delivery, the system assigns a rider, and for pickup, the system shows the restaurant location. Finally, the customer can track the order status and estimated time. For the admin workflow, the process is slightly different. First, the admin log into the system, then they can access the main dashboard and view and update the menu. The admin can also view customers' orders by displaying the order receipt. Finally, the admin monitors the delivery status, including the order status and the rider information. Next, I will explain the reporting and system output of the system. System output refers to the information displayed to users after they perform actions. For delivery orders, the system generates an order receipt that includes order ID, food quantity, total price, and order type. The system also shows the order status, such as out of delivery, and provides the estimated delivery time. In addition, the system displays the rider's name as part of the delivery information. For pickup orders, the system also generates an order receipt with similar details. The order status will show ready for pickup. Instead of rider information, the system displays the pickup location of the restaurant. These outputs are generated using different classes and functions. The order class generates the order receipt, and the tracking class shows the order status and estimated time. The delivery class provides rider information, and the pickup class provides the restaurant locations. Besides displaying outputs, the system also stores important records. User records store in login information such as username and password in the user class. Order records store details such as order ID, selected food, quantity, and total price. Delivery records store information such as rider name, order status, and estimated time to support tracking.
OOP concept overview. Our system is organized into three modules. Module 1, user management. Module 2, include menu, food, and order classes. And Module 3 have delivery, tracking, and pickup. To build this, we apply 6 core OOP concepts to ensure the system is flexible, secure, and logically structured. For array of objects, we use two types of array. In the menu class, we implement a dynamic array for the food list. Since the menu are not fixed, we need the flexibility to add or remove items. In the order class, We use static arrays for order item and quantity to support using loop operation to store order item for calculating the final price. In the user, food, and order classes, we apply data hiding to hide sensitive data like password and price using private attributes. Encapsulation can prevent unauthorized change by ensuring that only public member function can modify data such as update the price of food. In association, for the aggression, our food object exists independently of the menu. If the menu is deleted, the concept of the food item remains in our database. For the composition, order cannot exist without an order item, and delivery, tracking, and pickup classes tightly bond to the order. If the order is deleted, the tracking status and delivery details become meaningless. Inheritance and polymorphism. The user class acts as a parent to allow customer and admin inherit login and logout logic, which avoid duplicate code. We apply polymorphism in the dashboard. For example, customer can select view menu in the shopping dashboard, whereas admin can select check delivery status in the management dashboard. In this slide, we handle real-world errors by using try-catch blocks. If incorrect password, no rider are available for delivery, or a user try to order 0 items, the system throws a specific exception. Finally, our security elements use authentication to verify identity and role-based access control to define permission. This ensures a clear boundary. For example, customer can conduct orders, but only admin can update menus.